Hi, I'm Jeff Kaji, and I'm going to show you the basics of rocket science in 5 minutes. First off, what is a rocket? A rocket is a projectile that can be propelled really high or really far by combusting its fuel. How does that work? Explosions of fire. To make a fire, you need 3 main ingredients. You need fuel, you need oxygen, and a spark. Then, once we get that to explode, we shoot it out the back of our rocket, and thanks to Newton, we know that for every action, there is an equal and opposite reaction. Much in the same way a deflating balloon shoots air at the back, pushing the balloon forwards, shooting hot gas and fire at the back of our rocket can, in return, create a force that will accelerate the rocket forwards incredibly fast. Then, once the rocket gets into space, it'll be able to keep moving on that path without burning any fuel, because without any air resistance to slow it down, an object in motion will tend to stay in motion. That's it, right? Rocket science isn't that hard, right? Because, although a constant force gives a constant mass a constant acceleration, that's not at all what we're dealing with. For starters, as the rocket burns fuel, it loses some of its mass when it shoots it out the back. And due to factors such as adjusting the engine's throttle or the rocket changing its direction, the net force acting on the rocket is also subject to change. Due to this, the quick and easy formula we had before of force equals mass times acceleration turns into this. Nasty, right? And besides, to do rocket science, you need to know a rocket ship ton of calculus, which isn't that easy either. Anyway, besides all the math, rocket science can be kind of hard because, as you may have heard, space is enormously big. Rockets have to do some pretty insane things with incredible precision. For example, when SpaceX lands one of its reusable Falcon 9 stages on that barge in the middle of the ocean, it does so with the precision it would take to toss a pencil over the Empire State Building and have it land on the other side, upright, on a stamp. When its second stage delivers its payload to the International Space Station, it has to get there using multiple engine burns and maneuvers, not only to catch up with it, but also to make sure it doesn't go crashing into it when it gets there, traveling at 7.5 kilometers per second around the Earth. When we went to the moon in the 60s and 70s, we had to travel 384,000 kilometers to get there each way, which is roughly 100 times the distance from New York to LA. And the onboard flight computer was less powerful than even a modern graphing calculator. However, today, we do have graphing calculators and we do have super fast computing. What once took humans days or even weeks to do on paper can now be done in minutes or even seconds on silicon. With private companies investing in rocket science and aerospace, we are on the forefront of a new space age, a technological revolution. If you're a creative or a problem solver and are interested in space, there's an entire universe's worth of opportunity out there for you. Yes, rocket science may be difficult, but we do these things
not because they are easy, but because they are hard.
If you can set your mind to something and surround yourself by the best people in the best environment, then possible becomes achievable, and that's how history is made.
Now step off the limb. That's one small step for man, one giant leap for mankind. Columbia, this is...
So to everyone, especially all the aspiring rocket scientists out there, shoot for the moon, and if you're diligent and lucky, you'll make it. And also, maybe one day if I'm lucky, I'll be there too, doing rocket science and looking up at the stars.